Hello all. In today's video, we'll see how to construct an histogram and frequency polygon and their significance in the field of data science. Notes on the video have been provided in the download link below. In the previous lecture, we had seen what is frequency distribution. We saw what is group frequency distribution and continuous frequency distribution. Then we saw what are class intervals and also what is meant by inclusive classes and exclusive classes. Now we will see how to draw a histogram. The steps to draw a histogram are: firstly, we will convert the group frequency distribution into continuous frequency distribution. So what we are going to do is basically we are going to convert the inclusive classes into exclusive classes. And once you convert them into exclusive classes, the upper and lower class limits of these exclusive type classes will be known as class boundaries. Okay, this is the first step. In the second step, we will mark the class intervals on the x-axis, and in the third step, we will mark the frequency on the y-axis. Let us take the example we considered in the previous video. This is a grouped frequency distribution. So as per our step 1, we will convert this grouped frequency distribution into continuous frequency distribution. That is, these classes which are presently inclusive classes, we will convert them into exclusive classes. So what we are going to basically do is, as you know, in inclusive classes, like suppose if we consider the class 25 to 29, it will include the marks 25 and 29. But in case of exclusive classes, it will extend from 25 to 30 but excluding 30. Okay, so now let us see how to convert these inclusive classes to exclusive classes. Suppose if we take that the gap between the upper limit of a class and the lower limit of the succeeding class is d, then the upper class boundary is given by the upper class limit plus d by 2 and the lower class boundary is given by lower class limit minus d by 2. So if you see in our example, the upper class limit of the previous class is 29 and the lower class limit of the succeeding class is 30. So the value of d we will get will be equal to 30 minus 29. 30 minus 29 is equal to 1. So the value of d we got as 1. So our upper class boundary will be 29 plus 1 by 2, that is 29.5, and lower class boundary will be 25 minus d by 2, that is 24.5. So you see here our new boundary will be 24.5 and the upper boundary will be 20. So we have represented the new boundaries in the new table. So our new class is from 24.5 to 29.5. This is an exclusive class. Similarly, the other classes are like this. Okay, so thus we have converted our inclusive classes into exclusive classes, and now this is a continuous frequency distribution. So now we have completed step 1. In step 2, we will mark the class intervals on the x-axis and the frequency on the y-axis. This is our table. We have taken the marks on the x-axis and number of students or the frequency on the y-axis. Now we'll start plotting the histogram. So the first value is 10. So we'll create a bar with a height 10. Next is 14. Next is 14. Next is 29. Then 12. Then 20. And finally 1. This is the histogram for frequency distribution. Now you saw how we converted a grouped frequency distribution to continuous frequency distribution and then plotted the histogram. If you have a continuous frequency distribution, then you can directly plot the histogram. Now let us see the use of histogram in the field of data science. We can use histogram in data distribution analysis to find out what is the central tendency, dispersion, shape of the data, identify patterns, trends and outliers. In data exploration, histograms are used in EDA, that is exploratory data analysis, to find out whether there are any clusters or gaps in the data. Then histograms are used to identify skewness and kurtosis. In data pre-processing, histograms are used for identifying and dealing with outliers to achieve a more normal distribution. In feature engineering, they are used for creation of new features and transformations that improve the model performance. And during model evaluation, histograms are used for comparing the distribution of predicted values with that of the actual values, so that we can know whether our model is performing or not. Okay, these are the uses of histograms. Now let us see how to plot a frequency polygon. We will use the histogram that we have plotted before. Now what we will do is we will mark the midpoints of all the bars. Then we will connect all the midpoints with the help of a straight line. But this is not a polygon. Why? Because polygon is a closed figure made up of line segments. So what we will do is we will take two hypothetical classes, one before the first class and one after the last class with frequency as 0. Then we will mark the midpoints of this hypothetical class. Then we will extend the frequency polygon to the x-axis at both the ends. This is our frequency polygon. We can construct it by making use of a table also, as we have done it in the previous while converting it from histogram. Same, we will construct two hypothetical classes, one at the start of the class interval and one at the end of the class interval, okay, with a frequency as 0. Then we will calculate the midpoint of all these class intervals, and then we will plot the midpoint against the frequency, that is the number of students, and we will get a frequency polygon. Now let us see what are the uses of a frequency polygon. The uses of frequency polygon in data science are similar to that of a histogram. In data distribution analysis, we will use a frequency polygon instead of a histogram when we want a smoother curve instead of the bars. Okay. In data exploration, we will be using a frequency polygon to find out the data characteristics or to understand the data characteristics. Similarly, in comparison of distributions, we will use it to compare the shapes and the central tendencies and variability of different data sets. In identifying trends and patterns, we'll use the frequency polygon to see if the distribution is symmetric or skewed or unimodal or multimodal. Frequency polygon is used for highlighting the central tendency of the data. Time series analysis frequency polygons can be used to visualize the distribution of values over time. This is particularly useful for identifying patterns, trends, or seasonality in time-dependent data sets. So that's it for today. I hope you have understood what is a histogram and what is a frequency polygon. In the next lecture, we'll see averages or measures of central tendency. That's all for today. Thank you.